So for example 1, we want to estimate the area under the curve for f of x equals x squared on the interval from 0 to 3 using 100 subintervals of equal width and right endpoints. So this one, we could easily draw the graph of x squared, but trying to draw 100 rectangles would just be nightmarish. So what we've got given in this problem to us is that our n is 100, and we can calculate the widths of each rectangle by using b minus a over n. So our b is 3, our a is 0, n is 100. So the widths of each rectangle is going to be 3 over 100. So now what we want to do is we want to write down what the starting and ending point of these rectangles might look like so we can get an idea of how to adjust our graph. So the first rectangle, its left edge is going to be 0, but its right edge is going to be 3 over 100. Then the next rectangle picks up at 3 over 100 and goes to 6 over 100. So I got that by just adding 3 over 100. Then our next rectangle would start at 6 over 100 because they butt up against each other and go to 9 over 100. So what we're doing here is we're just trying to discern a pattern, and I can see that the last rectangle will go from 297 over 100 to 300 over 100. And so you can see here we started at a is 0 and we ended up 300 divided by 100 is 3. So this covers the entire region from 0 to 3, and each one of these brackets represents one rectangle. So since we're using right endpoints, we want to look at the pattern on the numbers on the right. And what we can see is that the right endpoints, which we're going to call C sub k, can be computed by the following formula. Three times k over 100. So when we draw the first rectangle, if we plug in k equals 1, we go to 3 over 100 and draw up. If we plug in k equals 2, we go to 6 over 100. If we plug in k is 3, we go to 9 over 100. And then when we get to 100, we have 300 over 100. So we know that this worked out. So now what I want to do is I want to see, well, if these are all the x values for all of my endpoints in the most general form, because I'm going to compute all of these at once, well, f of c sub k is going to be 3k over 100 squared. And so all I did was plug it into my function x squared. So now if I plug in 1, I get the height of this rectangle. If I plug in 2, the height of this rectangle. 3, the height of this rectangle. And when I plug in 100, I get the height of the last rectangle. So I can simplify this a little bit by saying this is 3 over 100 squared times k squared. So the reason I'm separating the constant from the k is because I know later when I pop it into a sum, I actually have a formula for k squared. So the area is going to be delta x times the sum from k is 1 to 100, because that's our n, of f of ck. So now let's plug in all the components. So the width was 3 over 100. The sum is from 1 to 100 of this formula right here. So we get 3 over 100 squared times k squared. Just to make this a little bit easier on myself, I'm going to pull all the constants out front. So I have 3 over 100 cubed, because I had a squared times another one, times the sum of k equals 1 to 100 of k squared. So now I get 3 over 100 cubed, and I actually have a formula for k squared. And the formula for k squared, right, is n times n plus 1 times 2n plus 1 over 6. So when I calculate it here, since my n was known, I'm actually just going to plug 100 everywhere I see an n. So that's 100 times 101. 2 times 100 is 200 plus 1 is 201 all over 6. So this is the approximate area using 100 rectangles.